My name is Oktay. Welcome to today's video about the images from the Great Hubble Space Telescope. In today's video there will be El Gordo. The telescope is named after Edwin Hubble. He revolutionized our understanding of the universe. His measurements made clear that the Milky Way is one of many galaxies, and the Andromeda galaxy is not a part of the Milky Way but another galaxy. Another feature of the universe is that it's expanding, and Edwin Hubble was able to measure this with the measurements of the redshift, the galaxies. The Hubble Space Telescope was launched on April 24th in 1990 in the Space Shuttle Discovery to Earth's orbit. This is a picture of the Orion Nebula, MSC 42 NGC 1976, at a distance of 1,344 light-years. This nebula has a diameter of 24 light-years. It contains 700 stars with a mass of 2,000 solar masses. The Orion Nebula was discovered in 1610 by Nicolas Claude Fabry de Peresque. This is a picture from Earth from the Orion Nebula, and you can see the interstellar cloud, and the Orion Nebula is a star formation region. This is another picture from Hubble, from a region with a diameter of 2.5 light-years. This structure in the middle is called Trapezium Cluster. It was discovered by Galileo Galilei in 1617. It contains 4 hot massive stars in the center. This is the Monkey Head Nebula, NGC 2174, at a distance of 6,400 light-years. Its diameter is 75 light-years. The Monkey Head Nebula is a H2 region. It contains ionized hydrogen. This structure is associated with the open cluster NGC 2175. And you can see in this picture stellar winds from the young stars in the core. This is the planetary nebula NGC 2818 at a distance of 10,400 light-years. This is an aging star which ejects its outer layers and is about to become a white dwarf. And our Sun, in about 8 billion years, will also become a white dwarf. This is the irregular dwarf galaxy UGC 7983 at a distance of 30 million light-years. It is quite isolated, and this could be how the earliest galaxies in the universe looked like. And at the left, you can see a picture of an asteroid. It has photobombed this image. This is the galaxy NGC 7090. It's a spiral galaxy. We can see it from edge on. It's at a distance of 31 million light-years and has a mass of just 5.5 billion solar masses. For comparison, the Milky Way galaxy at least has a mass of 800 billion solar masses. And this galaxy was discovered by John Herschel in 1834. This is N159. It's a stellar nursery in the Large Magellanic Cloud at a distance of 160,000 light-years. Its diameter is 150 light-years, and it contains many hot young stars. This is the Skyrocket galaxy, also called Kiso 5639, at a distance of 82 million light-years. It's a dwarf galaxy. You can see it edge on. And this again, another galaxy that is quite isolated. But we can see at the left a starburst that is caused by a rain of intergalactic metal poor gas. That's why the head is glowing. And the diameter of this head structure, this red structure, is 2,700 light. This is the elliptical galaxy NGC 474 at a distance of 100 million light-years. Its diameter is 250,000 light-years, so it's 2.5 times the size of the Milky Way. And you can see tidal tails and tidal shells. And this is the reason. Its interaction with this neighbor galaxy, NGC 470. The tails and the shells come from the galactic interaction, the gravity of the neighbor galaxy. This is the intermediate spiral galaxy, NGC 2276. Intermediate means it is between a barred and unbarred structure. It is at a distance of 120 million light years. Its diameter is 88,000 light years, so it's about 10% smaller than the Milky Way. And you can see it has an asymmetric shape. And this spiral arms, there's a starburst, and in one of the arms there's an intermediate mass black hole with the name NGC 22763c. It has a mass of 50,000 solar masses. There are three types of black holes. There's the stellar black holes. They have a typical mass of 3 to 10 solar masses, a product of the death of big massive stars. Then there's the supermassive black holes, and they sit in the center of galaxies. They have a typical mass of millions to billions of solar masses. And the intermediate mass black holes is the third group. That's the most mysterious group, because they are very difficult to detect, and it is not clear how they were formed, these intermediate mass black holes with a typical mass of few thousand to 50,000 solar masses. The reason for the asymmetric structure of NGC 2276 is in this picture. That's the action with its neighbor, that's NGC 2300, the right, and that's a lenticular galaxy. This is a galaxy formerly a spiral galaxy, which is about to become an elliptical galaxy. And NGC 2300 was discovered by Alphonse Borrelli in 1871. This is a beautiful galaxy, Makarian 1337. The distance of 120 million light years. It's a spiral bar galaxy, and about half of the spiral galaxies have a bar. This is a picture of 8 different galaxies and their green filaments. And the green filaments are from ionized oxygen, from a blast of radiation from a quasar. Quasar is a quasi-stellar object. It's a luminous electric nucleus. That's a supermassive black hole that's eating material, and the accretion disk, there's friction, and this causes the radiation. And this is the source of this green light. This is the Coma Cluster Abell 1656 at a distance of 323 million light years. It's a cluster of 1,000 galaxies, a diameter of 20 million light years. And there are 2 elliptical galaxies at the center of the Coma Cluster. That's NGC 4489 at the left, and at the right NGC 4874. The left galaxy, NGC 4489, has a supermassive black hole with a very high mass of 21 billion solar masses. For comparison, the supermassive black hole in the Milky Way, that's Sagittarius A star, has a mass of just 4 million solar masses. These are 2 galaxies, SDSS J1354 plus 1328 and 1327. And the smaller galaxy at the bottom is interesting. These galaxies are located at a distance of 900 million light years. The bottom galaxy has 2 gas outbursts from a supermassive black hole within 100,000 years. And the cone of the gas has a diameter of 3,300 light years. The galaxy cluster Abell 68, it's at a distance of 2 billion light years. This picture is caused by gravitational lensing, and this structure here looks like really like a game Space Invaders. And at the top right, you have a ram pressure gas stripping of a galaxy that is in a region of denser intergalactic gas. And this causes the stripping of the gas from out of the galaxy. And this is a picture of gravitational lensing. It was predicted by Albert Einstein's general theory of relativity. And matter bends space, and the light from the background object is focused to the telescope, and it can even appear several times. That's how this Space Invaders picture was made. And the background object can appear up to 4 times. Then it's called the Einstein cross. This is El Gordo. It's called the Fat One. It is at a distance of 7 billion light years. So this is a structure very young in its evolution. It's a galaxy cluster with several hundred galaxies. Its total mass is about 3,000 times the mass of the Milky Way galaxy. And you can see this galaxy cluster has a structure. Here's something. Here is another structure. And the next picture from the Very Large Telescope and Chandra combined of El Gordo shows you these are 2 colliding galaxy subclusters, and they're moving at a speed of 2,400 kilometers per second. This is again a Hubble Ultra Deep Field in 3D. It shows you the position of the galaxies in the universe, their filament structure, and the big gaps in between is called warts. And this is the scale model of the Hubble Space Telescope in Marshfield, Missouri, USA. And this is a very nice gesture, in my opinion, because Marshfield is the birthplace of Edwin Hubble. And that was today's video about the Hubble Space Telescope images with El Gordo. Thank you for watching. Have a nice day. Bye-bye.